Hi everyone, welcome back to a new year and welcome to another edition of Science with Mama J. So today we're looking at activity 6. So in the previous activities, some of the things that you've done is you basically observed some unidentified substances in a large container, and in an effort to identify those substances, and you made some observations about some physical characteristics such as density, appearance. And once you made those observations, you went ahead and you separated the substances into various containers. So you separated the solids out into one container, cleaned, and then you separated the two substances into two separate containers. Now you may notice that my substances look a little bit different. When you first saw the container, you saw that it was a lightish orange substance and a clear substance that was sitting on top of it. So, based on observations, it was easy to see that the clear substance was less dense and therefore sitting on top of the orange substance. So, my orange substance is lighter because, unlike yours was exposed to some metals that did manage to begin corroding inside of your unknown substance, and it was very hard to see the toxicity test. So, we're using these to make sure you could see how your test should have come out, to include the toxicity test so that it's easier to identify whether or not the substances are toxic. So we're going to go ahead and get started with the miscibility test. For those of you who don't know what miscibility is, it's the ability of something to mix with something else. So if something mixes and blends uniformly, it is miscible. If it is unable to be mixed, it is not miscible. Okay, an example of something that is not miscible is Italian salad dressing. You can shake it all you want, but the oil is always going to separate from the vinegar. So let's go ahead and take a look at the first test. And the first miscibility test is water. So we're going to go ahead and put 50 drops of water. Okay. And I'm going to put 50 drops of water in my second vial as well. Okay. So now we're going to go ahead and we're going to put substance A, which was a clear substance. We're going to put 10 drops in the first vial. And for substance B, we're going to go ahead and put 10 drops of that in the second vial. And then we'll take each and cap because we don't want to accidentally spill anything. Give it a little shake. We're going to let that sit for just 1 second, and I'm going to go on to the second miscibility test, which is in ethanol. So we're going to go ahead and take some denatured ethanol, and we're going to do exactly the same thing with the water. We're going to do 50 drops in each one. All right, so we've got 50 drops in each. Now we're going to go ahead and put 10 drops of liquid A. And 10 drops of liquid B. All right, give it a little bit of a shake and just leave it there. So let's go ahead and take a look at the water test while we're letting that sit. So looking at the first substance, it is clear that that substance is miscible. Okay, they blended and mixed together nicely. Looking at the second substance, and it is hard to tell, but I can see it clearly, however, you can't. But it is not miscible at all, okay? It is not miscible. There is a clear demarcation, a clear line between the two substances. They did not mix at all. So perhaps it would have been prudent to maybe put a little bit of food coloring or something in the water. Okay, but no, they did not mix. Okay. Second substance, ethanol. Looking at substance A, which is the clear substance. Okay, in this case, it might be a little bit easier to see. It may not be, but you may see a clear bubble sitting at the bottom. So the substance actually dropped all the way to the bottom, and the ethanol is sitting on top. Now, this is very interesting because in the water, the substance collected on top of the water, but in the ethanol, it's sitting in the bottom at a bubble. So whatever this substance is, it is less dense than water, but it is more dense than ethanol. So looking at the other substance, substance B, it is completely mixed. So substance A, the clear substance, is not miscible in either water or ethanol, but substance B, the orange substance, is miscible in both. Okay. So the next test we're going to be looking at is to see whether or not either substance contains water. Now, we're using cobalt chloride strips for this. I did not take the cobalt chloride strips in advance because this is Florida, and in Florida, it is very humid, and I did not want the cobalt chloride strips interacting with the humidity in the environment and affecting our test. So I'm going to go ahead and I'm going to put 1 drop of substance A on the end. And I'm going to do the same on a different strip with substance B. Now, while we're waiting for those to develop, I'm going to go ahead and take out my pH paper because we're also going to do a pH test for corrosivity. So while we're waiting for that to develop, which we can kind of already see what's happening, I'm going to put a drop of substance A on my pH paper and a drop of substance B on my pH paper. Now, while we're waiting for that, if we look at substance A on the cobalt strip, we see nothing has happened. But, and it may be a little bit difficult to tell, You might see a little bit of a pinkish there, but it didn't only turn pink, it turned almost a blood red. Now, if we're looking at whether or not it contains water, it says if the paper remains blue, water is not present. So substance A, which is a clear substance, there is no water present in that substance at all. Substance B, however, it turned very, very dark. There is definitely water in that substance. Now, looking at the pH test, substance A, once again, it did not change the paper very much. So comparing it, it has a pH. It looks to be here closer to 4, between 4 and 5. So it is somewhat acidic, but not very acidic. Looking at substance B, it turned very dark. It's got a pH of between 1 and 2. So substance A is not corrosive at all. The clear liquid is not corrosive at all. Substance B, on the other hand, is very corrosive. Okay, so it would present as an irritant. All right. Now, the last test that we're going to conduct is a toxicity test, and we're going to go ahead and use our CPUP tray for this. So we're going to take substance A, and we're going to put some of substance A in the first well. And then we're going to put some of substance B in the second well. Now, what we're looking for, again, is a change in color. If the solution does not turn red, the solution is not toxic. If the solution does turn red, then the liquid is toxic. So we're going to be using potassium thiocyanate as an indicator. Okay. So we're going to put 1 drop of potassium thiocyanate, and we don't see any change. However, when we put a drop of potassium thiocyanate in substance B, it turns red very, very quickly. So substance A is not toxic, but substance B is extremely toxic. So we've learned that substance A is not miscible in water or ethanol. It does not contain water. It is not corrosive, and it is not toxic. Substance B is miscible in both water and ethanol. It does contain water. It is very corrosive, and it is very toxic. So based on this information, you should look in your book and identify what the substances are and document that on your 5.1 sheet, the sheet that we started in activity 5. When you started identifying the physical properties, you're going to document that in the characteristic properties for the chemical side. And tomorrow we'll look at flammability. So I hope you enjoyed this lab. If you have any questions, feel free to leave something in the comment section, and I look forward to seeing you next time. Bye.